Hello guys, this is Nikhil Bansal from Illuminate Minds. Today we are going to start a new playlist. This playlist is all about writing coding problems in Python language, and these problems are based on number system. We are going to do 70 odd problems in this category. You can see the list. So we'll add the list also. So I've written only 18 problems at this point of time, but we'll keep on increasing it. This playlist is going to be important for you from two point of view. One is from the TCS NQT and WIPRO NLTH point of view, the coding section, and where the problem comes in. And from the other point of view, it's a technical interview. So let's say in a technical interview, somebody asks you, write down the program for factors for number and the count of the factors, and you write the same program, the traditional program that you have seen in your books or seen in some playlists also. Right, and then what the interview will think that he is giving me the same program the other guys have done it. So there's no differentiating factor for you. You need to write down the program which is best possible in terms of efficiency, less number of iterations, and that's what we need to do as a coder, isn't it? So that's how we need to proceed forward. Let's start the first program of the playlist: factors of a number and count of factors. So guys, this is the problem. Let's say there's a number 48. We'll try to understand from the theoretical point of view, from the number system point of view, in the quantitative aptitude section, and then we'll write the program for it also. So let's say there's a number 48 for which you need to find the factors. Since I don't know any mechanism to do it, what will I do? I will start writing all the numbers of the factors of the number 48 as I've written over here. And then I will count and I will say the count is 10. But this is not the best possible way. I hope you understand that. We need to find out some mechanism. So the other way of doing it is that we will write down number 48 in the prime factor format. How will I write down the number in the prime factor format? First, I need to identify the prime factors of the number 48. So what are prime factors now? Prime factors are the factors which are prime. So 2 and 3 are the prime factors of the number 48. So in this list of factors, only 2 and 3 are the prime. Correct. Now what will I do next? I will write down in this format. I hope all of us will be able to do this, how I have written this. So I have divided 48 by 2, again 24, 20, again 2. So that's how we'll reach to this thing, that the highest power of 2, the one of the prime factors of the number 48 is 4, and the highest power of the other prime factor 3 is 1. Okay. Now what? Now when we write this thing in this format, then we need to understand that the power of 2, this block 2 to the power 4, will provide me 5 choices. The 5 choices are 2 to the power 0, 2 to the power 1, 2, 3, 4. Similarly, this block provides me with 2 choices, 3 to the power 0 and 3 to the power 1. So if I combine any of these two, I will get a new factor for the number 48. Let's say if I combine 2 to the power 0 to 3 to the power 0, what will I get? I will get the number 1, which is one of the factors for the number 48. Similarly, when I will combine 2 to the power 1 with 3 to the power 0, I will get number 2. And 2 to the power 0 with 3 to the power 1, I will get number 3. Similarly. So, aptitude quotient says this, that this block provides me with 5 choices. These are 0 to 4. Hence, if I pick one of these 5 and I combine with one of these 2 choices, I will get the count of the number of factors. So, this tells me the total overall count is 10. I hope it's okay. Now move to the programming part of it. How will I write the program for it? I believe some of you must have seen this thing, and what you guys do is that you write the program from 1 to 48, right? You run the loop from 1 to 48 and then try to divide number 48 each time with number 1, and if it is found to be divisible, then you claim that number to be the factor of the number 48. The important point that you are missing in this particular way is that you are running the iterations from 1 to 48, so that means 48 iterations are going to happen. But this is not the right way of doing it, guys. Okay. So what's the right way of doing it now? The right way of doing it is, let's see, how can I reduce the number of iterations drastically? If you look at this, the factors are divisors also, right? So the numbers, the 10 numbers that are written over here are divisors also. So when in the program you write, I will write the program just, let's say, once I am done with the theory part of it. So 48 by 1, when you try to do this, you say that 1 is, since it is divisible, then you say that the number 1 is the factor of the number 48. But the important point over here is that if 1 is divisible, the quotient of it is also the factor of the number 48. So 48 by 1 gives you the remainder 0. That's perfectly okay. But the quotient 48 is also the factor. So you can write them in groups. Correct. So 1 comes along with the number 48. So 1 and 48 comes in pair. So why are you running the loop twice? Similarly, when you try to divide 48 by 2 and you'll claim that the remainder is 0, the quotient of it 24 is also one of the factors of the number 48. Similarly, 3 comes with 16, 4 comes with 12, 6 comes with 8. Now what to do next in the programming part of it? I need to run the loop only from 1 to greatest integer of under root of n. So that means in this case 48. 48 means what? Under root of 48 will give me 6 point something. The greatest integer of it will give me 7, isn't it? So I will write the program. I will run the program only from this to this. So that means my number of iterations in this case are 6, while what people usually do is number of iterations are till 48. So we will reduce the iterations drastically and we will print both the factors at the same point of time. Now there's a small glitch into this. Let's say the number that you have inputted is 49. Now what will happen? Now you will write 1 as one of the factors of the 49. You will get the output also 1 and 49 at the same point of time. But when you will write 7 and we'll try to divide it 49 by 7 and you'll say the remainder is 0. Now quotient is also another factor, but I cannot write number 7 twice. I need to write only once. Why this is happening? Because 49 is a perfect square. That's why it's happening. So there are two types of numbers. One which are non-perfect square and the other which are perfect square. So we need to take care of the numbers which are perfect squares. That's the only thing that I need to take care of. So I have reduced the number of iterations drastically. So let's start with the coding part of it, guys. So guys, let's start writing the program. So this program is all about prime factors and its count. So I'm writing out down this. The next thing that I need to do is I need to import math library. Correct. Next is I need to find out the count of the factors also. So I need to start the counter. So I'm writing it down as 0. So this will do? This will count the number of factors for me. So I'm doing two things at the same point of time, isn't it? So I'm doing two things at the same point of time. So what I need to do is that I need to find out the count of the factors also. Now we need to take the input from the user. Let's say num1 is our input from the user. I want this to be integer, so I'm writing down as int. So I will ask the input. I need to mention the clause also. What the user needs to input. That is input the number for which prime factors and count of the factors needs to be, and the count of the factor. Input number for which prime factors and count of the factor needs to be found. Correct. So this gives me the input. Now what I need to do next is the loop that we were talking about. Right. But before the loop, we need to find out to which limit that I need to go with the loop. That I will do math.ceil, which is math.ceil, and this will be under root as I discussed in the theoretical part of it. Num1 asterisk 0.5. So this will be till ceiling. So now I will try to run the loop. The loop will run from for I in range 1 to A. Correct. I hope it's okay. A is the under root of our input value. Now what next? The next thing is that I need to put is the range to the if condition, whether it's a perfect square or it's a non-perfect square. Yes or no, guys? So this a plus 1 will enable us to get the 7 in the range. That's why there was a problem, I believe. So now what? I will write 49 and this is done, 149.7, and you can see that 7 is being printed from these two statements and the count is moving only by 1, hence the number of counters for this. Let's try one more time. Let's try to run this for one more time. That's the number 100. Let's try to find out for number 100, which is a perfect square. So 1, 10, 2, 50, 10. Yeah, look over here. The 10 comes over here and the number of factors of number 10 are 9. So that's it, guys. In this video, kindly subscribe to the playlist and to the channel and keep watching the playlist. Thank you.